Here we have assignment 3 of CS2810. In this assignment, we in Logism make a bit, a register, and an ALU. So this is the bit right here. Basically, let's start the clock. And then whenever load is 0, nothing changes in the output when we change the input. But if we enable load, and then we switch in and out, or if we switch in, it automatically switches out. And then the cool thing is, let's say that the out is powered. If we turn off the load and then we change the input, the output just stays how it is. So this stores 1 bit of information. So with this, we make a register, which is, I think there's 16 of these. Yep, there's 16. So we store 16 bits of data, 16 bits of binary in this register. So it's kind of a similar concept. Right now, our input is, well, I guess right now it's storing these 4 ones. But if we change all of these data bits to be 1, and then we set the load, it changes the out so that they're all 1. And now if I change the input, it'll automatically change the output. And then I'm going to turn the load off. I can do whatever changes I want to with the input without changing the output. But now I have set the load, and the output will become the input. So this stores 16 bits of data. So that's it for the bit in the register. Now looking at the ALU, these are the function codes. Like these are the operators for my ALU. But basically, let's just store. These are decimal, these aren't binary. Let's store the value -5 in A, and B will have, let's put 12. So currently, with operator 000, which is AND, bitwise AND, we get the output of 8. That doesn't make a whole lot of sense in decimal. Let's find what addition is. 0, 1, 0. So if we switch the operator to 0, 1, 0, we get the sum of -5 and 12, which is 7. We can also do subtraction, which is 1, 1, 0. -5 minus 12 is in fact -17. And then let's see, we can do A is less than B with operator 1, 1, 1. So -5 is less than B. So if we set the operator to 1, 1, 1, this should be true. And you can see that it is. I'll demonstrate some of the bitwise operations. Let's switch this to, rather than being a signed decimal, let's switch it to binary, because it's an easier way to view what's happening here. So let's switch A to all 1s and B to all 0s. And then if we set the operator to 0, 0, 0, that's bitwise AND, nothing should pop up in the output pin, because it'll go through and it'll be, okay, 1 and 0, well, obviously that's 0, and it'll do that for all of them, and then our output pin will all be all 1s. But if we go to OR, which is 0, 0, 1, they'll all be 1s, because 1 or 0 is 1. So we can just like, here, let's I'll demonstrate the AND again. You can see that in the A and B pin, the only pins that are overlapping that are 1 on both positions are these bottom 2 left ones. So that's kind of an example of the ALU. As you can see, we got the logic, the AND, the OR, the addition, the A and not B, A or not B, and then this is addition or subtraction, and the less than. And then this is the 0 pin, which is only active, which is only on if our output is all 0s. Otherwise, it's not on.